Right, maybe you can't be here today for the presentation, so you only get one person. So if anybody feels that's bad value for money, there's other talks going on. Okay, so as some of you may know, we have like this kind of live install going on downstairs. So we've been very busy this week to try and develop this thing during the festival so people can see the process of how it's made. So this isn't going to be a very well-rehearsed talk where someone's been standing in front of a mirror the last 2 days. It's going to be one where someone's been up at 3 AM in the morning calibrating structured light scans. So bear with me a little bit. So I'm Elliot. I'm one half of the digital art studio called Kimchi and Chips. I'm going to talk about a bit about us, me, our studio, then some concepts in our work, and introduce some videos of our work. And then I'm going to talk a bit about this concept which has been running through a few of our projects, which is called digital emulsion. Okay, so first, Kimchi and Chips, there's two of us. We're based in Seoul in South Korea, and we've been working together for approximately about 5 years. And we make these projects with stuff. We're not very good at just making software projects and being able to do things just with our laptops. We kind of get addicted to things. We like to kind of make something which is physical. But we've also got this very much taste for digital objects, and we try to merge these two and make them overlap somehow. And we have these kind of three topics which are kind of recurring themes within the work. People, obviously, with interaction, nature, both in terms of how something's constructed, which is the nature of the object, but also nature in terms of natural forces like vegetation or wind and things like this. And obviously technology, how does that weave between these different things? How does it act as an agent in itself? We're kind of discovering technology, not really inventing it. We're finding out things which are kind of naturally work quite well. So we're kind of following down this path in different directions, and we see how these things interact with nature and ourselves. I'm going to, like I said, I haven't really kind of rehearsed this so much, so I'm going to skip through a few things. But we often at the moment we're always worried about how well we fit on this scale between opportunity and imagination. Imagination being you're sitting on the train and you look out the window and you go, okay, I'm really bored. What do I want to make? And you think about the things you want to make, and you kind of get this drive and you try and piece together all the things you're going to have to learn, and all the places you're going to be, and all the materials you're going to get to make this idea. And then the other end of the scale, you have this kind of other approach of someone gives you an opportunity, so they might be saying okay, we've got maybe there's an exhibition, or maybe it's maybe it's a corporate thing, whatever. And we're often kind of wondering how well we fit on the scale between these two things. How much is kind of self-initiated work, and how much is kind of being led by what else is going on out there. And I think a lot of the studios who are doing the most interesting work at the moment are the ones that are finding opportunity out there and refactoring it, reformatting it, so that they take what people don't know is out there, the people who are giving them the opportunity don't know that they're giving them, and they make it into something that's super interesting. Okay, so our studio is in Seoul in South Korea, and it's in one of these office towers here. It's not a particularly sexy place. It's not got exposed concrete or brickwork or anything like that. It's basically a business park. And down the road, we've got this big tool town where there's loads of manufacturing facilities. And there's things you can get anything made of aluminium there, or glass, or whatever you want. And then on the horizon, the Seoul in the background. The city of Seoul is just past these mountains. So a studio is a bit like this. It's kind of we hang stuff up and we plug stuff in. And this is a little video panorama which shows almost setting the project what it kind of looks like. So it kind of demonstrates a lot about what our process is. We've got kind of the artwork on one side, which is kind of the result, the output, but we've got this all this technology around it which enables it to happen, right? So you can also see in the background, you can see okay, we have computers, things like this, and a lot of structure, materials, and in the corner that's kind of my bedroom at the moment, and then just lots of things like this. Okay, I'm going to skip through this section a bit, which is like, it's kind of like some of the concepts that kind of come into our work, but like are kind of the borders of what we do. One of which is sharing is violence. So, I mean, you always come to these conferences and everyone's like, oh, I made this library, it's wonderful. And it's like, oh, such a wonderful person. And I kind of try and do that sometimes. I like, oh, okay, I made the software, isn't that great? But actually, like, if I give you a piece of software I put on free on the internet, I'm kind of encapsulating all my ideas in it, and I'm kind of perpetuating myself through the software, right? So if I make like a solution to a common problem, but I make it in my own image, and other people use that, then they're going to start acting within my image. They're going to start acting the way which I thought when I created that piece of software. So this kind of comes through like a lineage of like other things where people say something is violence. So like one of them which is translation being violence. So when you take words from one language to another, you're kind of like violently affecting the target language with source language words, which happens a lot from English to other languages. So when someone takes something from English and then takes that word and starts being appropriate in the other language, then the other language, the culture of the other language gets affected, right? So if I share my code on the internet, and it's got like all my code ways of thinking in it, and then this kind of gets used by other people, say it becomes a popular add-on for openFrameworks or something like that, then a lot of people will end up like traveling their imagination through my roots, right? So they'll have like their idea of what they want to make, but then they'll get my code and they'll say, okay, these are the functions I've got. So I've got to wander through this route to get to my target. And they'll get lost a bit on the way, and they'll probably end up making something that's a little bit affected by me. And this is like a kind of a common one, which is a lot of people are realizing right now, which is like vocations are starting to die out a little bit. You can learn how to use like AutoCAD off the internet from a 12-year-old, right? Like, I mean, we've probably all been there where we've like been like, I don't have to do something in After Effects, or I don't have to do something in Photoshop. You go to YouTube and it's like some like kid from the Midwest, and he's like, yeah, you click on this pattern here. And it takes like 20 minutes because you're like, he's not very good. Because that makes stuff, but the fact is like anybody can learn anything now, and you can download any software for free legally off the internet. So you don't need to be in a big institution to become an engineer, to become an architect. Obviously, like there's still a lot of value to like to taking it very seriously and spending many years dedicated to that thing. But I think it has a big effect where we don't need to really think about anymore about like, what are you? Like people say to me, what are you? And I say like, oh, digital artist. And I used to say media artist, and before that I don't know what to say. And there's always like, they kind of like this idea of a set kind of things that people do, like what kind of office they've got, what days do they spend working, what do they actually do when they're there. And then like you pin all these ideas together and you come up with the concept of what the person is. But I think like a lot of people in this room, you will probably have these lives where you're making things, you don't really know, what the output is, what the audience is, what the kind of like, what the kind of long-term goal of that thing is, or even like what you want to call it. But you know that it's important to do right now. Okay, so on to stuff. What was we talking about? No, okay. Right. So this is a common theme in our work, articulating form in space. So we create these installations where we try to create like forms which exist within space, but these forms are digital forms, right? So they have like all the possibilities of a digital set of things. They can like they can change in scale, they can copy themselves, they can like move very fast, they can like float around, but they actually exist within space. One of the first installations where we did this was one called Lit Tree, where we projected to a tree, and we tried to create volumetric, means something that occupies space, like projections inside the tree. And the way it works is, I mean, imagine a projector is like it's got these spotlights coming out of it. So each pixel is like a spotlight that travels through space, right? So like if you imagine you had like 1 million spotlights, like where I am now, you point them to the other side of the room, and each one makes a little pool of light, right? That's essentially what a projector is, okay? Now if you put your hand in the middle of that ray, then some of the pools of light are going to hit your hand, right? And those pools of light, you can actually say, okay, I know where that thing is in space. I know it's like 5 meters up that wall, 2 meters up this wall, 6 meters up that wall. I can give it a 3D coordinate for that pool of light. So each of these pools of light which hits into the tree will land somewhere, and each one will have a 3D coordinate in space. And then you can imagine that all these little pools of light inside the tree are actually then voxels, they're 3D pixels inside the tree. And then you can like try to create these volumetric forms by like selecting, so you can select all of these pixels that land like within a plane. You can rotate that plane around, or you can say, select a sphere inside it. And another kind of interesting side effect to this is that you kind of communicate with the tree in this way that's supernatural to the tree. The tree understands light, right? It's reacting to it with hormones inside the tree, which are released when the light hits it. And that means those sections where they get hit by light grow differently from the ones that are in complete darkness. So the ones that have no light on them kind of search out to try and find light, and the ones that are being hit kind of like are more stable and they kind of grow more healthily there. So we can kind of start suggesting a form for the tree to follow by giving these kind of complex patterns of light. I think then we've got a video now. I'm just going to switch my video mode around. That's better, right? And now, the next thing I'm going to talk about is that installation is called The Tree, and we made it in 2011. And it was the first installation in the series which we call digital emulsion, where we scan something with a projector and then we project onto it. And using that scan data, we can know where all the pixels are in space, and we can think about how these pixels are connected inside the tree. The next installation we made was inspired by Hegel. We mixed these kind of sparse structures. And sparse is S-P-A-R-S-E. It's a theme that's kind of continuing in our work, where we create these sparse sets of things. And we were kind of inspired by these kind of like meshes and ways in which these things occupy space, and wondering like how we can like kind of collaborate with these concepts to create something that's digital, which has these kind of wonderful like geometric qualities. So we started to sketch things out, and this is our pitch, the idea. We thought maybe we could like make this kind of like web out of strings. We could like maybe like project onto it and create this form in space. So we started doing some testing. In the studio? Ring? Hello? Has it changed? Sorry. We started doing some tests in the studio where we project into this like set of threads, and we get these kind of like geometric patterns back from the scans. So, has anyone seen what's going on downstairs? Okay, all right. First bit of audience interaction. Right, so we came up with a different installation, right? And we started sketching it out, and we started thinking like, okay, we're gonna like make this room with these threads in it, and we're gonna try and use it as like this sparse canvas, this spatial canvas. And one thing we started to realize from our previous installations as well was that a lot of our creative process, if you drew it like a Gantt chart, like if you drew it like a project management diagram, it's a bit like, you have to do this, then you can do this, then you can do this, then you can do this. And And the problem is, like, when you get into a space, you've only got a limited amount of time to actually, get to work on it. So we started thinking about ways we can kind of parallelize how we can, like, do something on one end, which allows, like, the creative process to continue whilst also solving technical problems. Because often, like, we end up stuck with, like, we spend 2 weeks trying to solve a technical problem, and everything else has to wait for it. So one of the things we did was we started developing kind of we made our own CAD application for this installation. So I can maybe show you that briefly. I don't can't actually believe it. So and then what we do is, like, you can actually sketch out these lines, and it means that people who, like, on the creative side, can start thinking about, like, what the kind of features of this structure might be like, so the technical side can react to that. So the technical side, we go, okay, actually, we never thought about the structure might be like this, and that causes these kind of problems. But it also means the creative side can start to get stuff working before we get in the venue. But for this installation, it's not pre-designed. It's not like we come up with a set pattern of how it is, and then follow that. We come up with some ideas of how it might be, and then when we get to this space, we improvise it, we recreate it. We end up with this kind of like wireframe of strings in a space, which has got some like macroscopic features that flow through it, and it's got a lot of these kind of like little pockets. And the idea is, like, these like little pockets that are encapsulated by like faces of triangles are like pockets of space, right? So it's the line which is there ends up segmenting this space, like cuts it. It cuts all this like empty space inside it with these very thin elements which override everything else. So there's always like emptiness in there. You're not looking at a very complete image like you look at a video image, but we're trying to like fill this space out with very, very thin bits and pieces. And of course, like, for this kind of work, there's a lot of kind of calibration, and what we've done is we've made like a few systems which have been refined here as well, and they're available online, so anybody can like look at how we do that, or they can use this code for the things. And obviously, like, when we have these kind of 2 stages, and one of them is to take a 3D scan. So we're going to do like a 3D scan of a room, which then we can reproject onto the object. So first thing is, obviously, we can say, okay, we can just project onto one string, right? So we've got a bunch of projectors in the room, we've got 2 up here, basically facing down to the strings, and we can say, okay, we can project onto any line, right? But then, like, we can also say, pick any line in the room that points towards a 3D point in space. We know, like, all these lines in 3D space, we know where they are, where they start and end. So we also know, like, this line here, does it point to this? Yes, it does. Does this one point to this? No, it doesn't, right? So we can make a vector map in 3D space, like made of physical elements. And we can also, like, just simply select, like, interesting objects. Or we can kind of get a bit more abstract with it. So we can, like, say, okay, we want to create, like, this continuum, a selection in the lines, which is based on some kind of generative algorithms. So I'm just going to show, like, a very early video of this, a very updated video, but it's very long, it's 5 minutes. So I'll just show this one now. Okay, so, and like I said, if you want to, if you're interested in that, there's a complete video of it online, which is Okay, the next project I'm going to talk about is outside of the streaming project. So like I said, we're treating this project line segment space. We're in this family of projects called digital emulsion. And then this other project, which we've been working on at the moment, is kind of untitled at the moment. It's going into a new territory for us a little bit. And the idea of this project is we get the wind to paint an object. So we have this flag of fabric. At the moment, the working title is lunar flag. We have a flag of fabric, and on the fabric, we project the intersection of the fabric with an object. And what that means is as the thing flows over time, it starts to render out an object. So we get this kind of sphere in space that's painted by the wind. So you can see like this process happening here. As the flag ripples, you can see, this is like a kind of deeper view on the right, where you can see what's going on the computer. There's like the idea of the sphere, and then here is like the kind of physical enactment of that. Does that make sense? Yeah. So you get these kind of quite interesting artifacts out of it, because like you end up like having this like digital system which is doing the scanning and all this lot, creates all these 3D scanning artifacts, and they come out as like actual artifacts in space. They become like realized, incorporeal through the installation. And basically, what we're thinking of doing with this is like having like this thing flow, like maybe in like an outdoor area, and then making these kind of prints, which are outputs of it, where each one is kind of like that moment in time where we've traded these two dimensions. We've traded the dimension of time for the dimension of space, right? And we create this light painting, which records into it that moment in time. Okay, so this is when it's going to start getting techie. That doesn't get you going then. Would be not sitting in the middle. Right, so this is stuff, right? This is material, this is rust. So we make things out of stuff, we make things out of material. We make buildings, we make tables, we make laptops. And the kind of the aesthetic of the material, both in terms of like how it looks, but how you like understand it, is the kind of is the ego of that material, right? So if you have like something like iron, then you can expect all these things that iron does. You can expect if you make something out of it, what the personality of that object might be, right? But I think like but also now like we're starting to get this like new taste that's been offered to us through the digital world, where we want our materials to be able to do things which they couldn't do before. So like we want them to be mutable. We want to be able to change them in any way after the fact, right? In the moment, we want to be able to change them. And we want to be able to tool them into like these kind of like complex shapes which weren't really possible before. So we need these kind of new materials which do that. So I think that a lot of what like these new canvas works, where people like our studio are making works, where they create technology which creates an opportunity to create an artwork, and then they create an artwork. We're kind of doing material technology. We're playing around with new materials. We have to start thinking about like what is it that we're making? What's the kind of constraints of that thing? And what is it good at? And I think like a topic which is worth considering, which like thinks about this is like an idea called the aesthetics of error, which means like to basically this tagline: the ego of the media is determined through the vernacular of its deterioration. The way in which the material falls apart tells you about the material. The photograph here, right? The big cat. It's always good when I'm sitting on this side because the cat's like that. The way in which when the film stops telling you the image, when it stops being fidelic, when it stops like giving you the intended output, when it stops responding to the design and starts talking about itself, is the film grain, right? When you look at a digital photo grain, it looks different from a film photo grain. When there's no grain, the kind of images look very similar. When the material deteriorates, like a brush does, it tells you about itself. It tells you the ego of the thing itself, right? This is going to be obviously true of these new materials that we come across, the way in which like a 3D print deteriorates starts telling you about the way in which the thing is constructed and the ego of that material. And it's also true of like truly digital materials like 3D scans. Like the way in which they fall apart, like these Connect scans, like they have these interesting artifacts inside them which tells you about the way in which the thing happened. The personality of the device which does the scanning is recorded into everything that comes out of it. So, I think that it's interesting dichotomy when you make an installation is, like, are you presenting a system which is running and has its own personality, or are you presenting an intention within which you're trying to diminish the personality of the system? If we create an installation, I'm just going to jump a slide, which has like all these artifacts in it, do we want to get rid of them so we can have complete control and diminish the personality of the system, or do we want to basically, that is the artwork in itself, that's the encapsulation of the thing that we are presenting. Right, so I'm going to talk about this idea now called digital emulsion. And it's this new idea, I think it's relatively new, which has been shared through a few projects. And basically, like, it's related to this one field called projection mapping. This is where the transitions start coming in. And there's obviously like a lineage of projects which like have things in common, and like, I mean, obviously some people don't like it anymore because they've just heard the word so many times. It's funny, I think, because I think like it just relates to like a whole bunch of work, and it's kind of tied around this like title, which means so many different things to so many different people. That's kind of maybe what makes people frustrated. But anyway, there's this kind of like field projection mapping, and there's like obviously there's a lot of work within the buildings, large surfaces. There's also like kind of new interesting work like Johnny over here. And there's like there's kind of different directions to go with this, but generally what you're trying to do is you're trying to think of the way a projection addresses a surface, which is not a trivial surface, right? So the surface is a building. The surface is like got loads of intricate details on it, or so forth. Another field which has obviously been quite popular, has been quite important, is 3D scanning. So a lot of works recently have been employing the information that's available in the 3D scan to create a kind of a digital view onto the world. And these two things, like, I don't think there's very many things which very well link these two things together. I think like a lot of people in the projection mapping world have like wanted like more automatic projection mapping, and the answer to that has been like through 3D scanning. But that isn't to say to take all the ideas of 3D scanning or what 3D scanning thinks about, what its natural outputs are, and incorporate them together. So this kind of new field is like something which is trying to do that. It's trying to link together like what information, what the beauty is in a 3D scan, and what you can do with it, and what the possibilities of using projection mapping to bring that stuff into the real world are. So the 3D scanning is there to like give you this information, right? It's there to give you this like digital aesthetic of the way a computer sees the world. And projection mapping is usually there to like impose a designer's aesthetic onto the real world. And digital emulsion, what it does is it says, let's reapply a computational aesthetic onto the real world using technology, using projectors. Oh, yeah, and also like, we're not really so sure what the name is. Like some people call it reprojection scanning, which maybe, you should write these things down because I really want to start saying these things. Let's do that again. This is my kind of vibe and share, I think. I'm trying to make this into a thing, basically, right? Digital emulsion. But the thing is, like, it doesn't tell you what it is in the title, so maybe we should call it reprojection scanning or something like that. So the way it works is, we have this thing called structured light, and if you like project it onto something, it kind of distorts around the object which is projected onto, and we can take photos of that, and it tells us this super interesting thing, which is where is every projector pixel in 3D space, right? Now we can use that to say, okay, all these pixels in 3D space, okay, now we know where they are, we can say that's a scan of someone's head or whatever. But it's like super interesting as well, it says, these are where the pixels are in space. If we reproject back out, I know exactly where each pixel is, one by one at its 3D location. And also one by one, I can say, how does it relate to the other pixels around it? So we do this scan, and then we do triangulation, which is to kind of trace back these pixels. So say this camera pixel is this projector pixel, it crosses over here, and this one's over here, and so forth and so forth. And then we get this dichotomy of this kind of dualism between the 3D scan of the thing and the thing which we can actually reenact back onto, right? So we can reproject that 3D scan back onto the object and start playing with it, start augmenting it. And that's what we do with the installation downstairs. Not sure what's on this slide. Oh, text. So just a few notes. I'm still working on this. I'm trying to make a primer document which kind of describes what this paradigm is. But essentially, like, the projector is used both as a scanner and as an augmenter. So it's both doing the kind of like the data in and the kind of like stuff back out. Right? So you can think then that each projected pixel then is a sensor in the space. As you project onto something, each sensor is giving you readings back. It's telling you how bright the location is that it hits, where it is in space. So I thought of like this funny term, which I guess I'll have to put into the urban dictionary somewhere, which is a sexel, a sensor pixel. Oh, is it on the screen? Yeah. There we go. Yeah, the urban dictionary does have some definitions for this word already. One of which is a pretzel, which is folded over in the form of the Kama Sutra. But I think like these aren't very heavily used. Maybe we can get around this. So yeah, so you have these sensor pixels, right? So pixels which are sensors at the same time. Like you imagine like you throw these pixels out to something, and then you also like reading stuff back, and each one you can imagine it's like a little computer which is kind of enacting on the stuff around it. So they become like this fundamental particle for a new digital material. So going back around to thinking about this idea of material, digital emulsion being a material where it has certain constraints and certain properties and possibilities. So the fundamental particle of this material is the sensor. And then the ultimate aim is to kind of have a convergence of the possibilities of digital and physical materials. So digital materials don't only exist within a computer, but they can act on real-world objects. And everything like digital light is like a semi-material. It's something which like has a lot of material properties. It changes the way something appears. It can change like reflectance, shadows, and things like this. But you can't touch it, so you can't really kind of like, there's no kind of a tactile response. So it's got some material properties, and it lacks others. And the reason why I say digital emulsion is because it's a bit like milk, where you've got the fats and the solvent and water which don't mix together, right? And like one is suspended in the other. So this is a chemistry lesson now. I'm going off track. But you've got this kind of liquid, and there's all these like bits of milk inside it, but they don't really dissolve into each other. Like one's suspended within the other, right? This means that like these two things don't mix; they just kind of like exist in the same space. And I think this is like what digital emulsion is. It's like you've got physical stuff and digital stuff in the same space. They don't really mix. You try and create a continuum of one within the other. Right, and like I said, this is where it does get very, I think we're running out of time. So one project which I've been working on is this idea of a digital emulsion engine. So like our projects which are using digital emulsion to project onto things, they don't do it in real time. They can't be affected by the material. So if you move your laptop around and you have this material applied to it, then it's going to stop working straight away. So I started working on this idea of a digital emulsion engine. So the first thing you have to do is take a projector apart. Just a quick lesson on how projectors work. Over here you've got the light that comes in from this direction. Over here you've got the image coming out from the lens, right? In the middle you've got this DLP chip, which basically like is like a pad of mirrors. Like it's like 1,000 by 1,000 mirrors, and each one of the mirrors like can turn on and off like this, right? If it turns on, then the pixel's on. If it turns off, then the pixel's off. So it's white or black, right? So to get grayscale, it just does it really, really, really fast. It does it like 400,000 times a second, right? So in fact, it can actually project, like I think it's 40,000 black and white images per second. So it's like super, super fast. Now, because they're black and white, but they're really, really fast, to get color, we cheat. What we do is we send the red image, then we send the blue image, then we send the green image, right? So we do that using a wheel, a spinning wheel of color filters. So first of all, the red color filter comes in, it projects the red image, then the green, blah, blah, blue, blah, blah. So we use the fact that it's really, really fast to be able to project the images one after another. So if you take the color wheel out, this is kind of what it looks like. It's got these color filters on it. And newer projectors have got more and more colors to get more natural tones. You can imagine, like, if it projects the red, the green, and the blue, what you get. That was all going to come out like in the classroom. Wise. Alright, okay, so if you project but then inversely, if you project this image through a projector, it's going to project the red image, then it's going to project the green image, it's going to project the blue image, right? So if you take the color wheel out, it's going to do the same thing. It's going to project them one after a time, one after another in time. And this is what you get. You get like black and white images of regularly, right? Let me just change the shutter speed on the camera. So the idea is like this structured light stuff, this kind of like stuff that humans don't really want to see, or like it doesn't make any sense for a human. Perhaps what you could do is you could use this like super fast like projector setup to present them invisibly, imperceptibly. So the idea is instead of doing these three subframes as red, green, and blue, you give one for the computer, you give another one which basically cancels out the first one. So this is the opposite of that. Right? So you see that, and it's like super fast. It's just going to look like gray, right? It's going to be like white plus black, and the other one's going to be black plus white. Add them together because they go super fast. They're both basically 50% gray, right? So you make a system where you basically present one image for the computer, one to cancel it out, and then one for the human. So what you get is, what you see as a human is you see this one. And what you do is you synchronize a camera to see that one. So here's like a quick example of it running. So we run the system at 120 frames a second, and each one of those frames has got 3 subframes. And this is what the camera sees. It sees structured light. So it's able to produce a 3D scan in real time. And this is what the human sees. You see the image which you're trying to project on top of it. So this is just purely academic at the moment. There's like, I haven't got any good demos of this. There's no art projects that have come out of it, but kind of start to think about like, how we can start using a lot of the kind of new technology we've got around to create engines for new materials. And the output ultimately is that the scanner is a live 3D, the projector is a live 3D scanner, right? Where we have these voxels going on. So it's a voxel machine. I don't think I do have any time left, do I? Is anyone going to keep me out?
You got the power lines free.
Really?
Yeah.
All right. So anybody wants lunch? I don't want to make it look like you're impolite if you do want to leave. I know some of you probably do want to eat at some point, but I can just keep on going if that's all right. Okay. Cool. Right. Let's get augmented again. We don't see in 3D. This is a bit annoying when you're making all these 3D installations, right? You make an installation which exists in 3D space. It turns out humans are really rubbish at seeing in 3D. We're not like MRI scanners. We don't see like a volume of stuff. If I do this and I do this, it's not like the whole world collapses and like everything turns into Super Mario Land, right? It's like, it's pretty much the same thing. Let's say, I get like a little bit more like idea of like how distant things are, but it doesn't make it aesthetically different. So this is a window. This is a window with a beautiful vista beyond, where you're looking out from your yacht, which you're in now. If that was a real window, would it be visually very different from this situation now where you're looking through it? You'd get a lot more dynamic range. You'd see it was really bright outside. You get a sense that this thing's really far away. You'd have much more resolution. The color would be so much better. But is the image different? Is the actual thing that's being portrayed in your brain, is it fundamentally different than if it was than if that image was through an actual window? Right? So we go to another example that we are carrying on. So this guy lives in a 2D world, and we're gods, we're 3D beings that exist outside of this 2D world. But then, so in this argument, Mario should see in one dimension, right? Because he can't see around, right? So you can see He sees like this. And if you can't see through the blocks above him, because he's got his one eye over here. So his view looks a bit like this, right? So this is first person Super Mario. Still waiting for this to come out. Okay, so let's try a different angle, right? So we kind of like, we see surfaces, we don't see through them. Like you're not an MRI scanner, you can't see the stuff that's going on behind me. I occlude this. You're looking from a point of view, which is your head position, and it sees all the surfaces around you, and you collapse them into your view. You project them into a 2D view. So now what is a 3D world then? I think like a 3D world is an interactive generator of 2D views. It's like this supernatural interactive environment where we can explore it and understand what's going to happen when we move our head, right? It's going to be quite repeatable. We're going to have a very intimate relationship with it. But essentially, it's kind of like this object here, right? It doesn't make any sense. It's just showing reflections. It doesn't make any sense in 3D. If you showed me the mesh of it, it's not interesting. You have to show me from a point of view in order for this thing to even exist. You have to show me from a point of view which allows reflections to happen. If you don't have a point of view, there's nothing to see from that reflection, right? Does that make any sense? So then, like, the end of this paradigm, we're like designing in 3D for 2D projections. We're kind of like making things that are 3D purely so then we can see them through 2D, right? So this, like, very boat, it looks beautiful, but it only looks beautiful to us because we look at it in these projections and it creates all these great lines. And like, if we stick two 2D views together, we don't do 2 + 2 = 3, that doesn't work. You know, we can't just say we've got 2 eyes and therefore, you know, we add this information. We could say that we get more information about each point we see, and we can see how far away it is. But that doesn't give us a 3D view, I would say. So I think this is the paradigm which everyone likes right now, that like if you put your hand out like that, you've got a rectangle, and that could be an iPad, and it could have a camera on the back, and it could be somebody else's camera, right? Like every rectangle is a viewport. We really like this. We like the laptop, we like the web, we like the Oculus Rift, right? So these rectangles. And then he's got this dream where he's on top of a mountain, right at the top of a mountain with his iPad, and he's got a great Wi-Fi coverage. FaceTiming his wife. And she's like living through this rectangle. He's living out her living room through his rectangle. But he doesn't want to kind of hold her disembodied head in his hand and like point it around. He doesn't want to kind of like imagine like this kind of the neck fades out and she's kind of like gazing around. You don't want like this truly like 3D physical experience to happen. What kind of is very convenient is just like we section out this space and we say that space is that bit and that's that bit, right? And this happens to your work as well. So like if you make an artwork, then this is basically how it's seen by 95% of people. It goes down this tunnel towards the viewer. So it's a bit depressing if you make a work which is principally supposed to be spatial and 3D, experienced by the internet. So we started thinking about this, and we started trying to create an installation which kind of both describes to the 2D way in which we see the world, but also has these kind of spatial features that we've been playing around with. And one of the big spatial features we really like is something we call visual mass, as in it feels heavy. Like there's something in the room that's heavy, that's massive, that's kind of like got kilograms in it, but it's completely digital, right? It floats around, it like feels like it's right there. So we kind of had this sparse set of things again, and we started working on this installation where we thought about having like a set of 2D screens that are suspended in 3D space. But we want to have a lot of them. We don't want to have we don't want to have like 1,000. We want to have like 10,000. So each one of these screens is going to be very low resolution. It's not going to have like many features like it's going to create like a detailed image in each one of these things. But it's going to contribute towards like a big 2D view, whilst also contributing towards like a 3D volume, right? So it's going to draw together. And it's like this, so this thing is constructed essentially out of like acrylic blocks, and it's drilled one end a bit thin, one end like a little bit wider, and then we put these little bits of steel to hold it in place, and then we hang it. And then the other side of it, we have 5 video projectors, each one of which is teamed up with a machine vision camera. And these sit around the installation to cover every side of every block with pixels. And every morning, it automatically wakes up and it goes like, hey, how's it going? Having breakfast? Time to scan. And it projects out these patterns into it, figures out if any kids knocked it last day or something like that. And then it reprojects into it this scan set. And it also tries to do some clever things like tries to figure out which pixels belong to which block, which side the block is facing in, these kind of things. And then you get this kind of emulsion, this suspension of digital material within physical space, where one is overlapping with the other. This space here is overlapping with both digital and physical. So we're going to have bonus material. It's going to be